Hello everybody, hope you're having a good day today, and today we're going to be doing part 4 of the Tic-Tac-Toe series, which is creating the AI. And here I'll show you an example of the AI. So I've made it so that it usually takes the center, because in Tic-Tac-Toe usually good strategy is to take the center. And let's say we don't know what we're doing, and we can see that the computer took the win along the diagonal here, and we can play again, and you can actually tie with this AI, but it's really hard to win against it, and I actually haven't done it yet. So let me attempt to tie. So as you can see here, we tied it, and we can also change it if you want to, so that you start first, and that can be done later. So I hope you're interested in this, and you hope you're excited. Alright, so let's get started. So last time when we left off, we had this, and then it was a 2-player game at that time, so we could play with another person. Now we want to make it so that the computer moves. So most of our work were basically before last time when the move pressed, we made it so that the other person can make a move, and then we changed the turn. So that stuff won't happen this time. Instead, we're going to make a method called a computer move, and that's going to be the AI moving. But before we get onto that, I want to fix a few small things here. So just here where we have the diagonal wins, right? I just want to, instead of making it checking for null, we're just gonna make it check if the value is empty or not. And I mean, it sort of does the same thing, except if there's no piece there, it's not necessarily null, because that's how we initialized it at the start. So we want to make it so it's like not equal to the empty string. So I'm gonna put a not there, and same thing here. So we're gonna do dot get value, and this is all code that we've written before. It's nothing new. It's just I'm adding this to it, so it's a better check than checking if it was null or not. So I think that's all we needed to do actually in the board class, so that should be good. Now, I mean in the Tic-Tac-Toe API class. Now let's go to our board class. So here is where a bunch of stuff is gonna happen. So how I did it is I added a variable here, a field to this class, and I said it's a boolean that says if the player move has already been done. So if the player's already made a move. And here I can initialize it in the constructor to false, but it's automatically going to do that anyways, but we're just going to do it to keep everything consistent. And a lot of stuff, and actually this is where the update method here is going to come into play. So we're actually going to have update in here. So every time here, what we're going to do is we're going to actually change turns here instead of another place. So if at the start, current turn is going to be equal to an empty string, right? We know that because we're initializing it here, as we see that. So what we're going to do is here we're going to change the turn so that the current turn is going to be api.change current turn, or essentially it's going to change to the O pretty much, right? So we're basically changing it to that. So we're going to be X, right? If we're changing turns and we're passing an O in our API, we remember that if it's O, or if it changes it to the other thing, so it changes to X. So that's going to be us, essentially. So then we're going to have, now this is where our boolean is going to come into play. So if the player move has been done, so it's been done. So now it's the computer's turn to move. I'm just adding a null check here just in case, because sometimes the board was null and it was throwing null pointer. So if the board is not null, then we're going to call this method that we're going to make, which is going to be called computer move. And we're going to also change the current turn here. So essentially we could just take this code here and copy paste this part, but instead of passing in O, or here we passed in 0, I mean O. So instead of passing in O, we're going to pass in the current turn. So it's going to switch, basically going to switch everything around. And then we're going to say player move done is false, because now it's the player's move after the computer has made its move, right? So now another thing we're going to do here is we're also going to calculate the winner in update, because it doesn't make sense to calculate the winner on the move press method, because it's only going to work when we click on the board, because the computer isn't physically clicking on the board. So that wouldn't make any sense, because then the wins would be off and it wouldn't make any sense for the user either. So instead we're going to calculate the winner here actually, and essentially we're just going to call the same thing that we had before, and this is essentially what we're going to call. And then we're going to do the same check that we had before, and it was if the winner is not null. then we and also we checked if the piece is like not empty and all that stuff, right? Get piece, so it makes sure that when we initialize everything, it doesn't automatically say it's a winner because everything is an empty string. So we checked if it's not this, right? And then what we do is we make our winner found boolean that we had from before that was doing all the drawing and stuff here, down here, all this stuff. Then we can make it true, so then it knows that we found a winner. And also another thing we do is, if from last time as well, if the winner was null, right? If the winner found was null, because when it's a draw, this is accounting for a draw. So when we find that the winner is null, that means it's a draw. And well, not necessarily a draw, but if the moves made is a 9, because there's only 9 squares on the board, that means we know that has to be a draw. So again, we're gonna make winner found true, but the thing is, we have this check here, in here, which is making sure if the move made is 9, then we make it a draw result. So we're passing it to our API to draw the result for us. So that this part right here really saves us, and it's not too much work over here. Alright, so that's pretty much it for the update method. There's no other changes in the draw method, but now I'm gonna add this other method here, which is gonna be called a reset game. Or we actually have it, but I'm gonna add stuff to it. So actually, we can do that later. It'll make more sense if I add it later. But essentially, all we're really going to add is we're going to make the player move done false. Just like how we did it in the constructor, we're basically resetting the game, essentially. So that's it for the reset game, actually. It's pretty simple. Now comes move press. So a lot of stuff is going to change here, actually. So what we don't need this anymore, because we're not going to change turns here anymore after the mouse is pressed, because it's automatically going to change to the computer, right? And what we're gonna do here is we have like this stuff, and that's cool. That's all we need, right? And then we're gonna set a piece there, and we're already moving. So this stuff is fine here. This is what we want. So this stuff is good. Now here we will basically make sure that we don't need any of this anymore, because we're already doing the winner stuff above, so we don't need any of that. And one last thing is, when we're doing moves made, we're going to change the current turn here, right? Because we know, and before remember that if statement that I deleted, that was deleted because at the start we had an empty, but now since we're putting in an update, our game loop here is actually very important, and it shows, and really goes to show what it does, is that it updates the thing 60 times per second. So it runs a 60 FPS kind of thing, and it calls the update and draw method. And here in our update, we're actually going to call board.update. So that means now that our board update method is going to be called 60 times per second. So that's really good, and that's going to make sure nothing is like, we don't miss any win checks or anything like that. And automatically at the start of the game, there's going to be a current turn, and it won't be the empty string. So we don't really need to worry to check about it if it's empty or not. So all we gotta do is just call change turns here from the API, and just pass in our current turn, and that should be it. And then lastly, on this segment, we're just going to add the player move done is true, meaning that the player made a move, and we can go on now, and the computer should make the move. Alright, now here comes the big chunk, which is the actual computer move logic, the AI pretty much of this entire thing. So first things first, what the logic of this computer move AI is pretty much is as such. So we're gonna get a copy of the board that we have. So we're gonna get a copy of the board, and what we're gonna do is we're gonna basically foreshadow or look ahead and try to see if the computer were to move to this position, is it better for him or is it worse for him? So what that means is, first thing we're gonna see is if the computer's gonna take a move, right? And if it can take a move and that is a winning move, like it wins the game, and we'll check that on the copy so it doesn't affect our original board. That means if that move is a winning move, then the computer will play that move first, no matter what. Second, what we're gonna check is if the computer moves and the other player can win, and like if the computer moves to a place and the other player has a chance to win, that means the computer won't make that move. So the computer will stop that person from winning. And then third thing is we're going to take the center if the center is open, because the center is a really good strategy in tic-tac-toe. And then lastly, we're going to take any of the edges that are available if none of those are there, any of the corners or edges. So that is sort of the logic behind this. So it'll make more sense when I write it out, but you'll see what I mean. But that is essentially the logic. So we need to make a copy of the board. So I'm going to call this temp board. I'm going to call this copy board method. Now, since arrays in Java are immutable objects, so it's going to be a little bit more interesting, and that's why I need to basically transfer everything over. So let's go ahead and write this copy board method actually. So what this copy board method really does is it essentially is going to return an array, a 2D array. So it's going to return a 2D square array, and it's going to be called copy board, right? And then we're going to get we're basically going to get another 2D array in the parameters, and that's the one that we're going to copy into and return. Copy and return, yeah. So, oops, and that's going to be, I'm just going to call it B, just to keep it simple, for B for board, right? And here it's going to create another one. It's going to be the one that we're going to return, and it's going to have new square, rows and columns. And also, it's probably better here to do b.length and p.0.length, but I'm just going to do rows and columns because in our case it's not changing. And what we do is we're going to take all the elements from the B 2D array and then put it in this. So it's going to be less than rows I++, right? We're going to need that 2D array structure, just like any time with 2D arrays. And what we're going to do here is we're going to create a new piece, a new variable, and a new row, and the variables are going to be new row and column variables, because we're going to create a completely new square in this to return. So it's a complete copy. Otherwise, it's going to affect, and since the square is actually an immutable object as well, it's going to affect the other square on the board, and it's going to get messy when we try to use the copy board. So this is actually very important because of that. So we're actually gonna have to create new pieces altogether, and all we're gonna do is just gonna take these, right? Get piece. That's all we're gonna do. We're just gonna get the pieces that the board already has, like the location of the board. So essentially, we're just gonna do this, and we're gonna get row, and then we're gonna do a column for that as well. So what we're essentially doing is getting the row, column, and the piece at the specific location in the 2D array. So what that's gonna get us is the values. And now what we're gonna do is actually in the to return, what we're gonna do is at that location we are gonna make a new square. So we're gonna make a completely new instance, right? We're gonna create a new square, and we're gonna pass it this row and this piece and this new piece. We're going to create a new piece. We're not passing it this because if we change this, then it's going to change the board as well. So we're going to create a new piece altogether, and then we're going to pass it this piece's stuff. So new get value, then we're going to pass it the get row, and then the column, not get row and then column. Oops, can I not spell? Okay, get row and then get column. So doing this allows us to create a complete copy of the 2D array, and it allows us not to mess around with the immutability stuff, so it doesn't mess up when we foreshadow in this computer move method and try to look at different moves. So that's essentially the copy board method. That should work for us. So now let's get into the logic of the computer move. So first thing, I'm gonna have a few other variables here. So I'm gonna have a temporary winner. So when we check for winners, I'm not gonna use our winner variable that we already have. I'm gonna use a temporary winner, and then I'm gonna set the string computer to be, as I said, it was gonna be the O, but we could change that if you want to. And the player move is gonna be X, or play move is gonna be X, just to keep it simple. So now what we're gonna do is here we're gonna do, if the computer has a chance to take the winning move, it takes the winning move. So I'm gonna call it, I'm gonna just write comments here and say take the winning move. And what we're gonna do is, again, in fact, I'm just gonna copy this this double for loop because we're gonna need it everywhere anyways. And it's all, and hopefully this doesn't confuse it, but it's just a normal double for loop going through the rows and columns. So what we're gonna do here is we're gonna check if that temp board, if temp board at ij, right, if that p is, and we're gonna get the piece and we're gonna get the value, okay, and what we're gonna do is we're gonna check if and make sure that it's equal to, it's actually a space that where we can move to, so we don't like this, because the computer doesn't write over something that we don't want that, right? So we're gonna make sure that this actually is an empty space, right? And what we're gonna do is we're gonna do temp board at I, and then j, right? And then we're gonna set a piece. So just like how we did it for the moving for the person, we're gonna set this piece here, and we're gonna create a new piece. I'm gonna pass in the value as the computer move, right? And then I'm gonna do I plus 1 as actually the row count and the j plus 1. And now what we're gonna do is we're gonna pass this board instance to the temp winner or to our API, and let it check that, oh, is this a winning, you know, combination here. And I'm passing in 3, but we can just pass in rows and columns, it'll work too. So now we're gonna check if this move is winning. If this move is winning, well, first we'll check if it's like not null and the winner, like the temp winner. So we're gonna first check if the temp winner is not null, so meaning that there is a winner, and the winner, like from the field that we have, has not been determined already. So that means there's no winner in the game, and this move will make the computer win. So then what we're gonna do is we're gonna access our board and play this move. We're gonna set it. We're gonna do the exact same thing actually. So essentially we could take this exact same code right here and put it here, because we're going to set it into our original board. Now, be aware, this is our temporary board, this is our original board. What this if statement is saying that we found a winner. So I mean, we know there's a winner because the temp winner is not null, and there's no winner that has been determined. So I mean, the winner is null. So that means we can set this, and that means the computer will be the winner. That means there's a winning move to be made. So that we'll just set this piece, right, and then we'll make moves made plus plus, and this one we're going to return, because that means we don't need to go down and check for the other stuff, because we know this is the winning move, so we can just get out of this right off the bat. Otherwise, if there is nothing like that and then the winner is null, right, so then what we do is, that means if the winner is null, and also that means the temp winner is null because it didn't go here, so it's not null, and the winner is null, that means there's no winner determined yet. That means we can do is we'll just set this temporary board exact like the location where we did here. We're gonna set this back, essentially back to an empty space, so we don't, you know, mess with it anymore. That means it's still an empty space and something can move there later on, and it doesn't affect our chances of like winning. So we're just gonna reset it if it doesn't work, and we're just gonna set temp winner to be null. So this right off the bat actually finishes the taking the winning move. So we basically loop through the entire 2D array, we take a position that is empty, and we place a piece there, computer piece there, and we check, okay, is this a winning move for us? And if the winner is there, if it is a winning move, then it'll go into this if statement, and it'll set the piece in our original board, and the moves made will be incremented, and that means the computer will win. If it's not, we're just gonna reset everything back. We're gonna make it back to an empty, and then we're gonna make temp winner null, and it's just gonna keep going on. Okay, now the next part of it is where we want to stop the player from making the winning move. So we want to stop the player from winning. Right. So what this is doing is essentially, I'm just gonna copy this double for loop again, and here what we're doing instead is we're gonna check essentially the same thing, except we're gonna do the exact same stuff. We're gonna place it there, except what we're gonna change is our if statement. So over here we're gonna see that so here we can also think of this as this. So if the temp winner is not null, so again from this logic, if the temp winner, we're gonna place a piece somewhere, and then we're gonna check if it's not null and the winner is null, right? That means we can play a move here. Why? Because that means the opponent is not gonna win, because the winner is still null, right? So that's gonna be very important. So we can just play computer move here, and that will allow us to, you know, play another move, and it'll be a little bit more random in that case, and just make moves made, increment this, and just plus plus and return. Now this is we're putting this in the original board, but here in our else, and this is not going to be an else if here, and it's just going to be an else. If else, that means there is a winner like the opponent can win, right? And so what we're gonna do there then is we're just going to basically, alright, so essentially here, let me just, okay, I just wanted to fix one small thing here. So here where we've been doing IJ, I made a silly mistake as I said before. This has to be JI, and that is because just how the 2D arrays and how our rows work. And essentially the column, like the location is going to be the row location. It's just flipped essentially, and we just have to be aware of that. And otherwise everything else is good. We just need to finish this, stop the player from winning, right? So again, let me just change this to JI, right? So okay, and so what I was saying here is, now since it's gonna go to the else if there is a winner, like the winner is not null, and then temp winner is also like not null, right? So then what we're gonna do is we're gonna set the temp board, and here instead we're at JI, we're gonna set a piece, right? Oops, we're gonna set a piece here. So we're gonna set a piece here, and this is gonna be back to an empty. So we're just gonna reset everything, and essentially what this is gonna do, and we're gonna make temp winner null. So this is just a reset, and what this essentially means is that if there is a winner, we're just gonna reset, and we're gonna keep trying to find the way until we find a way to stop the player from winning. So essentially what we do there is basically make sure that it gets reset, and then we can play our move here just like how we did here essentially. And just here, the small difference which I will point out here is that the temp winner here is not given the board, it's giving the temp board, just to make sure, just to fix that there. Otherwise, you know, it's going to calculate the wrong stuff, and we don't want that, right? So that should be good for also here as well, so this place as well. So just to lastly reiterate, stop the opponent from winning. So again, we're iterating through the array, and then we're placing a piece, right? We're making sure it's like an actual valid piece, and then we're playing the player move, not the computer move, the player move, and then we're checking if that is a winning value. So if that is a winning value, that means it's not null, right? Because we're checking if the player were to move to that piece, to that position, if that's not null, that means the player's gonna win. That we're gonna play the computer move there. Essentially what we're doing. Here we were doing the computer to see if it was winning. Here we're doing the player to see if it's winning. If it's winning, then we're gonna play it there. If it's not, then we're gonna reset it back. So that's what we're doing there. And then here, what we're doing is if we're checking if move to center if open. So we're gonna move to center if it's open. So, and we're doing this because it's actually a really good strategy in tic-tac-toe. So what we're gonna check is we're gonna check if board at 1, which is the center, dot get piece, oops, not get class, dot get piece, dot get value, right? And we're gonna check if it's empty. If it's empty, then we'll move to the center as if we have no winning moves or like that. So what we're just gonna do is I'm gonna basically take this and just make it set piece, right? So set piece, and then we're gonna set the computer to move there. So comp, and then we're just gonna make it 2, 2. So just like how we were doing I plus 1 here, J plus 1 here, just doing 1 plus 1, 1 plus 1, so 2. And then moves made, and then we're always gonna return, just because we don't want to keep going down this method because there's no need to, right? And it's gonna mess a lot of stuff up too. Now, lastly, this one's just gonna be, if there's nothing left, we're just gonna select a corner, select one of the corners, or we could do the edges, but I'm just gonna do select one of the corners here. And again, double for loop, right? What we're gonna do is we're just basically, instead of all this, so what we're gonna do here is actually, I'm gonna randomize the I values here. So I'm gonna randomize this, so I'm gonna make it a math.random, so it's a bit more random, and it's like not it's not too obvious of where the computer is gonna move. So it's gonna be range of the rows, and then it's gonna be in the range of the columns for J here. Oops, not the math.random part, right? So it's gonna be in the range of columns here. So now, or I mean, we could, yeah, it's gonna be the same, so it's gonna be in the range of columns. So we're gonna make sure that board at JI is not empty again. So dot get piece dot get value. So as you can see, we're doing this a lot here, and yeah, it's going to be pretty important everywhere just to make sure that the place isn't empty. You can also do a null check, but I didn't make it null, I just made it so it's an empty, so it was more like the first part of our episode of the tic-tac-toe series. So, and here what I'm going to make sure is that we're not going to a center piece. So if we're going to a center, that means I would be 1 and or J would be 1, right? So we don't want any of the centers because we already did that here. So we want to move to the corners, and essentially what we're going to do is now we're just going to set it at J and I. So basically, essentially, we really don't need a for loop for this, like a double for loop, but I'm just doing it just to keep it consistent here. So here I'm gonna pass in the computer move, and then I'm just gonna do I plus 1 J plus 1 again. So, and then move is made, and then return, and then return. Right. All right. So that should be it. Except there's one last part that I want to add. Is for the, actually no, I think that should be it. I mean, we can add another part, and I added it here just to make it a bit more random, and that was outside, and this is for the edges. This is not needed, but it can be added if you choose to want it. So again, same double for loop, because this is pretty much how everything with 2D arrays is going to work for us. So especially I'm just going to check if this is just for like a random place if it's open, essentially. So if there's no like really open corner, it's just gonna move to one of the places that's really open for it. So this is for that, but I don't think it's necessary, but I just added it just to get all the use cases, or all the cases pretty much handled. So again, we're just gonna go to J and I, and we're just gonna set the piece there. So as you can see, the temporary board was really needed for the winning check, the winning thingy, because we were actually placing pieces on the board. So we were calculating ahead, and that's really why it was needed. Otherwise, it was not necessary for the other part of the AI. But essentially, this is almost done. So we're just going to increment moves made, and then we're just going to return. So so this should, I think, work. Let me just make sure we aren't missing anything. I don't think we are. So, and let's just run this to see. Okay, so before we run it, let's just make sure we have everything good, so we don't have to worry about any errors that might pop up. So make sure that board.update, you're updating the board, obviously, because we have this update method here, which is responsible for the computer move and the winner checks and all of that stuff. So yeah, again, here we're changing turns, and I made player move done true here because I wanted the computer to move first. We could make a false, and then we would have to move, and then we'd have to change a little bit of the stuff. But I made it true here, and I made this false here. Then here again, reset game, I made it true, and I don't think there's anything in draw or ask to play. So mouse pressed here, I've changed some stuff up. I added this to make it equal to X, so the current turn is equal to X. Then we're going to like set the piece, and then we're going to change turn, and then we're going to make it true. It's not false anymore. And then we have computer move. Everything is the same about computer move. Just make sure, you know, here we're having I plus 1, we're having I plus 1. We're going to do moves played. Make sure you have your returns. Make sure you're doing J comma I, because again, that's how the rows and columns are working, right? And when you do and it's just how it works, and that's how 2D arrays kind of work. And this was columns, sorry. And this is how, and this should work. This should all work for us. Tic-tac-toe API, all we changed was this, right? We just made sure that the value, if it was, we just, instead of checking for null, we checked if it was empty string. And then here everything else should be the same. So let's go ahead and run this, and we should see automatically that the computer takes the center, because that's how we wrote our logic. So you see it took the center. Then we can play, and let's say we don't know what we're doing. See, the computer, if it finds a winning move, it takes the winning move, just like how we did it. Then see, is it here? And if we can win, here it could take the win, so it didn't have to stop us. But here, if we can win ever, it's going to stop us. But this is also a winning move, so it took that. Then here, as you saw, I played that, and I could have won here, but the computer stopped me from winning. And here, you see it's going to win. And yes, you can tie this. It's just a bit hard to do so, but there you go. And so I hope you enjoyed this tic-tac-toe series. This is the last episode, and we finally reached our goal of making the AI for it. And there'll be more more series coming up soon. Hope you have a good rest of your day. Please like and subscribe. You know what to do. Hope to see you later.